What's up, everybody? George from SME here. And today I'm doing a video that's basically an update of my video from last year where I compared the differences between data warehouses, data lakes, and databases. Because technology moves so fast and all these new technologies and terms are being thrown around that it's sometimes hard to understand. So I'm here to simplify it and give you my thoughts on the state of data in 2021. So let's start by just talking about the title, choosing the right data, insert place here. I think it's something that's really critical because there's so many different data technologies out there that I think that before we get going, we should look at the usual suspects. So first, you got your database. Pretty sure that everybody knows what that is and has worked with one in their time. Now you have a data warehouse where you're able to consolidate data and report off of it and basically be your single source of truth. If you want a big data solution, you can opt for a data lake where you can park your files across everything in your business and put them in one central repository. But you can then take those repositories or warehouses and build out data marts for your individual users or use cases. Now, be careful because if you don't take care of any of these, they become a data swamp where it's hard to fetch data. Basically, they become unusable. But now, if you want to blend some of these solutions together, some companies are using what's called a data lakehouse, and others want to call it a data cloud. And soon enough, we're going to be in a situation where we're putting our data in a data abandoned blockbuster. Obviously, I'm kidding. But seriously, this is just so confusing because there's so many different terms out there. And because these terms are popping up so quickly, someone who may have just gotten a data lake or data warehouse may think, oh, I'm already out of date. So what are we actually doing here? And really, at the end of the day, we're working with files. We're putting files somewhere and we're retrieving them through a specific mechanism. I know it's an oversimplification, but I think that it was really what we're doing at the end of the day. But how do we do that revolves around four different things. It revolves around where we're storing the data, the structure of the data, how we're able to process that data with compute and memory, and who is managing the data. So let's go ahead and break down each of these four categories, starting with storage. Now, traditional databases were built on these proprietary file format systems that you could retrieve through query languages such as SQL. Well, there was a term getting thrown around called NoSQL, where really it's not no SQL, it's not only SQL, document databases using JSON structures. And there was a heated debate on whether these were better than databases, especially when these distributed databases started coming out. So I think the debate is still raging on, but it really comes down to your use case and when you want to use them. Then you have data lakes that were built on top of Hadoop or HDFS, where it was a proprietary file format system that was open source and that allowed you to use massive parallel processing across your data lakes and really solved a lot of good use cases. Well, more frequently, or I guess more recently, now you have object stores, especially in the cloud, where you're able to leverage the power of cheap storage, but in technologies that allow them to be easily queried, easily fetched. And I think that this is going to be the future. I think that the object store is really going to become something that you see is going to be used for data lakes, data warehouses going forward. Now, let's talk about structure. And I think the best way to do it is to show this graph because it really does paint the perfect picture of the different types of data structures, where at the very bottom, you've got your most structured data, which has a definitive data model. And this is like your traditional RDBMSs, so your relational databases. Then you have semi-structured data, which is more like JSON and XML, where it's stored in a document style tree. But there still is an apparent pattern and you can still analyze them. But at the end of the day, there's also unstructured data, which a lot of people work with in their personal life. I mean, text documents, PDFs, images, and videos, you can't really say that there's a specific structure or a specific field that's inside of a YouTube video, for instance. So the thing to note here is that some storage options do not support things such as unstructured or semi-structured data. The lines are being blurred a lot more now, and I think that's a good thing because people are not going to have options. But just keep in mind that certain structures will only work with specific storage options. Now let's get to the process. And I have a fun little analogy here because really when it comes to processing, we're thinking about the combination of compute and memory and storage and how those play together. So in more traditional systems, you have storage bundled with compute, meaning that if I wanted to ramp up my server, I would have to upgrade my CPU, my memory, and my storage all at the same time. Think of this as a Taco Bell box where you have a certain number of tacos, you have your drink. Drink could be storage. If I need to upgrade my drink, you're probably going to upgrade the entire box as well, which would be your compute. So nowadays, companies are getting smart and being able to separate storage and compute so you can scale them independently, meaning that they are decoupled. So if I want a cheesy gordita crunch as far as my compute and my storage is a Pepsi from Taco Bell, well, if I want to scale up storage, get a large drink, I don't have to get another cheesy gordita crunch. Now, there is a rising trend of being able to just essentially have your storage, bring that to the table, and then bring an entirely different compute engine to the table as well. So I would call this separated entirely, meaning that if I wanted to get my compute as a Chick-fil-A sandwich, but I also wanted my drink, my storage as a Baja Blast, so I can go to two different places and bring them together to work together. So one thing to note here is that when you have this separated entirely, now you're looking at the difference between processing, meaning that maybe you're running something like Spark to transform the data, or are you using something like a distributed query engine so you could visualize or build a semantic layer on top of that storage layer? So let's wrap this up and talk about management. So traditionally, people would have to manage it through the use of their IT department, where they would have to patch the server, they would have to run updates, upgrades all themselves. Well, nowadays, with the rise of SaaS, people are now moving to companies that are able just to offer a fully managed solution in terms of their data storage and processing needs. And you probably will end up having to pay a little bit more, but you're not managing that infrastructure. The software company is, and usually patches, upgrades, all of that stuff is done behind the scenes relatively quickly. And I think that that's where a lot of the market is shifting towards. So, George, how do I choose? What you just showed me all these different options, but you really haven't figured out what is the ideal situation or the ideal use case or technology. So I think it boils down to two things on what you're going to do when choosing your data storage and processing solution. The use case. As mentioned before, all of these different technologies do things in a slightly different way, but certain ones are better. When we talked about structure, I mentioned how certain technologies such as data lakes can hold all three structure types where databases cannot. That's a pretty simple example, but you can see how each of these technologies and the way that you analyze your data, as well as the query languages or the programming languages that your users are familiar with, that's going to have a major impact on which technology you choose. And budget. Some of these technologies are pricier than others because they have maybe more bells and whistles, they have more scalability. So it's really going to come down to the blend of the use case as well as how much you're willing to spend on your solution that's going to help drive this. So that's it, guys. I really think that this is a topic that I'm going to continue to evolve on because it evolves just in the background of our lives. But I wanted to bring it to you, so break it down into a simple way so that you can understand it. So if you guys want to learn more about data solutions or need help in trying to figure out what is right for you, just drop me an email, send it to info@smesgroup.com, and let's start a dialogue. Let's have a conversation and see what your data needs are and if we can find that right technology to suit it.